Okay, and Mr. Cooke, do you think that it would be more expensive to, of course, we don't know what those requirements are yet. The government part hasn't done their job yet to see what those requirements are. But once they do you think it will be more costly or less costly to proceed with having Delta and Atlas meet some of those qualifications and meet those requirements versus the $9 billion that we have already spent on Ares and Orion that hasn't gotten us anywhere?
I really can't speculate until we do solicitations and get
proposals. Mr. Young should answer that too.
If I can answer a couple of your questions that you, if the chair would allow. I've got to go back, allow me. When you mentioned airplanes, good analogy. I'm a big admirer of our airplane industry. Even today, airplanes, it's a very mature industry. Airplanes land every day with problems that would be catastrophic in the human spaceflight program. Every day. They've probably done it while we've been having this hearing. So I think the analogies, are interesting but not directly applicable. If we come back to the requirements, and I think what Doug Cooke said of NASA levying the requirements for safety is a good thing to do, but I'll remind all of us that the reason things fail today won't be in those requirements documents. In other words, the requirements will not say, don't confuse English and metric units, which is the reason Mars 98 failed. It won't say, don't write down the wrong number in the guidance equation for a Titan IV, which is why a Titan IV failed. It won't say, don't let the foam hit the leading edge of the wing. And the only thing point I'm really trying to make is the requirements, the safety requirements are important, and they should be done, but they won't get the job done. What will get the job done, repeating again, is the strength of NASA and the incredible strength of industry, working together to make these items happen. You mentioned the launch vehicle, EELV. Two comments. First off, the EELV started out as a commercial enterprise, as you know as well as I do, obviously.
Yep.
There were a large number of space system failures. I chaired a review for Lockheed Martin. Sheila Woodall chaired one for Boeing, looked into that. And Larry Welch chaired a presidential commission to look into the launch vehicles. And out of that, the presidential commission's basic conclusion was that EELV proceeding as a commercial system when the commercial market fell apart and didn't really happen, were following practices that were not consistent with the practices that we knew were necessary to make these things have a sufficiently high probability of success. So the EELV program was changed, and it was changed to implement techniques that we have experience with, that we know how to make these things work. So EELV is no longer, really a commercial system. And your other comment about we could certainly take the EELV and we could human rate it.
Right.
Aerospace did a study. They said it would take between 5.5 and 7 years to do that. I must admit, I'm kind of struck by it being that long, to be honest, but that's what they said. They identified no basic cost advantage. And in addition to that, what I know about it is that if what you would like to do is to take your initial space transportation system that you went back and forth to the space station, and you'd like to be able to grow that to, and I'm now working your economic equation, you'd like to be able to grow that to a heavy lift, you'd like not to have two systems. And there's no question in my mind, and Doug should currently comment, no question in my mind, you can grow something like an Ares 1 into a heavy lift capability much more efficiently than you can grow an EELV into a heavy lift capability. And I think, again, if you go back and look at the details of that aerospace study, it'll kind of support that. So, again, the point that you and I have really been discussing, and I always enjoy my discussions with you, I should say.
Thank you.
And by the way, it's a terrific example of what I'm trying to say, is I end up with better thoughts having debated with you, and I hope maybe you have a date with me.
Absolutely, thank you.
And that's really what I'm talking about, is how NASA and industry works together.
Yes, sir.
Thank you, Mr. Young, and thank you, Mr. Rohrabacher. we're gonna about draw to a close, and because we're expecting votes shortly. But I want to just ask, as we close here, Mr. Cooke, in reference to Mr. Rohrabacher's point, what new technologies has Constellation developed?
In the Constellation program, we actually have some technologies we've been working that will be potentially migrated into our technology programs. Automated rendezvous and docking is one that we're working on the Orion. In the upper stage, we're making further progress on the technology of friction stir welding. We are working composite structures. We've made some advances in lightning protection on space vehicles, advanced batteries. We're using advanced solar arrays on the spacecraft. We are making advances in guidance, navigation, and control, and other avionics software that will be possible. We've actually in advanced development work out at Ames, we've developed technology in thermal protection system for advanced thermal protection systems for spacecraft. We're working in closed loop life support, and we're actually charting some new territory in modeling of the environments and characteristics of spacecraft during launch and entry through new modeling techniques and software.